When it comes to looking at statistics, the first thing we look at is what we call measures of central tendency. And all that does is measure the middle. Now we have three different ways that we can look at the middle of a set of data. The first one is the mean, which is just the average of the set of data, and that's where we add everything up and divide by the number of numbers. The downside to the mean is that it's really affected by extreme values. So if you thought about, maybe your grade and averaging your grade out, well, if you got a 0 on one or two things, that 0 is really going to pull down your average score. And that's why we need other measures of central tendency, like the median, which is actually the number that is in the middle. Like if you lined them up from the smallest number up to the largest number, the median would be that one that's in the middle. Or the mode. And the mode is the number that appears most often, so it's the most popular. The mode is most popular. Now sometimes with a set of data, we might have more than one mode. So if like one number shows up 5 times over here and a different number shows up 5 times over there, they're both the mode. And if no number shows up more than once, then there is no mode. And that just says that each piece of data is unique. So let's find the mean, median, and mode for the wait times at a certain doctor's office. And here we've got them all collected, and we've got them all listed in order. So first let's find the mean. And we denote mean by this X bar, capital X with a bar over it. And all we have to do is take all of these values and add them together. Once we have that total, divide it by the number of numbers. Well, since there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them, we're going to divide by 9. So you got to break out the calculator. And when we add all of that up, we get 198. Still have to divide it by 9, so the mean is going to be 22. The median is just going to be the one that's in the middle. So if we kind of started crossing them off at the ends, first and the last, next, and the next, and the next, that one that's left over in the middle, that's the median. And the mode, of course, is the most popular. And since 24 shows up twice and everything else shows up only once, 24 would be the most popular number. Let's do it again for some other office when the data set is a little bit different. The process is pretty much the same. If we wanted to find the mean, we're going to do the same thing, add them all up, and then divide by the number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers, we divide by 10. Grab that calculator to do all the calculating for you, and we'll get 168 divided by 10, and our average is 16.8. The median, of course, is the one in the middle. So you start canceling things off, just looking to find out what's in the middle. And we get down to it, and there's 2 of them actually that are in the middle. If you end up with this situation where there's 2 numbers that are in the middle, what you got to do is add them together and divide it by 2. You have to find that number that's halfway between them. And in this case, it'll be 17.5. And the last thing is looking for the mode. And when we look, every single number shows up only once. None of them are repeated at all. That means that there is no mode. You wouldn't say 0 for a mode because the most popular number isn't 0. You have to say that there is no mode. Now measures of central tendency, the mean, median, and mode, those things measure the middle of a set of data. Measures of dispersion measure how spread out the data is. And we have 2 main ones that we're going to look at. The first one is the range of the data, and that's the difference between the minimum and the maximum values. It's not saying that the data goes from 2 to 100, it's saying that the range is 98. So there's a little bit different there. The range is just one number. It's not the minimum and the maximum. It's the difference between them. And the hard one, but the one that's going to be real important to us, is what we call a standard deviation. That measures the typical distance between the data and the mean. Now, how we find it is through this formula. You're going to want to write this down. But we have this symbol. I'm going to write it again. It's like a little circle with a tail at it. That's sigma, lowercase sigma. And what it is a fraction where we're going to take the first data point and subtract it from the mean. Then square it. Add that to the second data point, subtract it from the mean, and square it. And keep going through the whole set of data till you get to the last piece, subtract it from the mean, and square it. Add all them up, divide it by the number of pieces of data you have, and then take the square root. Right? I'm not going to really get into where this comes from, but this is the process that we're going to have to use. So let's do it on just one of those sets of data. We have that office A. This is the same set of data we found the mean, median, and mode for. So we already found out that the mean was 22. So if we want to find what the standard deviation is, the first thing we're going to do is take 14 minus 22 and square it. And then take 17 minus 22 and square it. We're going to do that all the way through up to 32 minus 22 squared. All over the number of numbers, and we'll count that list again. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data, and then we have to square root all of this. So let's find all of them differences first. 14. The difference between 14 and 22 is 8. It's actually going to be negative 8, but we're going to square that, which will get rid of the negative part. Difference between 17 and 22 is negative 5. Difference between 18 and 22 is negative 4. Difference between 19 and 22 is 3. The difference between 20 and 22 is 2. Oops, these are all negative right now. But now when we switch over to the difference between 24 and 22, we get 2. 24 and 22 is 2 again. Difference between 30 and 22 is 8. And the difference between 32 and 22 is 10. All that has to get divided by 9 and square rooted. Alright, a little bit more calculating. 64, just plug away at all these numbers. It does take a bit of work. The work isn't difficult, but it takes up space. All I'm doing is squaring each of these numbers here. 8 squared is 64, and 10 squared is 100. All over 9, and then we square root. So I'm going to grab that calculator, add up the numerator. I'm going to get 290 divided by 9, and we still have to square root it. 290 divided by 9 is 32.22 repeating. And then when we square root that answer, I'll get 5.676, which is the standard deviation. Which, remember, it isn't talking about the middle. It's not talking about the mean or the median or the mode. It's talking about how spread out are the pieces of data. And basically what it's saying is that on average-ish, each piece of data is about 5 units away from the middle. We can also find the range real quickly just by looking at the minimum and maximum. We see that our data goes from 14 up to 32. So all we do is take that 32 minus 14, and we'll get a range of 18. There we go. That's how you're going to find range and the standard deviation.